Federico Cangialosi, is it correct? Almost. I'm sorry for that. He's an environmental engineer with a PhD in the Technical University of Bari. He's also a lecturer in this university for 6 years, correct?
Right.
Okay, right. And he has an expertise in designing waste and wastewater treatment plants. It's also a member of UNI and is a designated member by UNI in the same working group 42 since 2022.
Yeah. Thank you, and good afternoon to everybody. This is the last presentation of the day, and I will be short as is possible. And this presentation deals with the case study, real application of IOMS and other techniques with one main objective. The main objective of this presentation is to make an example of what two common important terms, which are odor management plan and odor reduction program, can be applied in the real world. As you know, these two terms are from a vocabulary from the bad conclusion of 2018 for waste treatment plants. And as you know, by the next year, so August 2022, all the plants must comply to the bad conclusions or the waste treatment plants. And so bad conclusions are very relevant in terms of odor management plan and the odor reduction program. So in this presentation, I will talk about this application. The site description, is a very large landfill, is a non-hazardous waste landfill. Mostly the wastes are sewage, sludge, and wastes derived from mechanical biological treatment of urban wastes. As you see, is very, very large, and the distance from the first receptors is 1 kilometer. The area emission source, let me see. Okay, the area emission source is here, is the first lot, as a surface of 130,000 square meter, and the specific odor emission rate here is ranging from 0.2 to 0.1 odor unit per square meters per second. And also in this area, there's a tipping area where fresh wastes are daily delivered, which has a size of 2,000 square meters, and the specific odor emission rates varies from 0.7 to 9 odor unit per square meters per second, obviously depending on wastes. Okay. I don't know what happens. Sorry. The landfill biogas management system, which is important in this presentation, as we see later, is comprised of 301 vertical wells, and there are also 2 energy recovery engines with about 1 megawatt capacity, and there are also 3 blower flat facilities with a capacity of 2,000, 1,500 normal cubic meter per hour. The odor management plan of this landfill, the odor management plan was divided into 3 sections. The first section is the source monitoring. As a prescription from the local Environmental Protection Agency, we carried out a monthly campaign of biogas monitoring from the landfill surface, according to the UK Environmental Agency Guide to Monitoring Surface Gas Emissions in Landfills. And we carried out this monthly monitoring campaign, over 160 points for each campaign. And so you see here in this graph, we have the month of monitoring from January to August, and in the y-axis we have the 75 percentile of methane surface emission in terms of milligram per square meters per second. And you see here that when we start in the period, in the summertime, from May to August, the concentration are around the limit set by the UK guidelines, which is 0.1 milligram per square meters per second. So we have a critical situation as an average, and we have local areas with very high surface emission rate of methane. And on a voluntary basis, we carried out also a detailed investigation with optical gas imaging technology in order to understand which was the cause of such emission from the surface of the landfill. And you see here, from the preliminary leak detection and repair screening carried out in August, we look at a lot of biogas leaking from the well junction, as you see here. And so we decided to carry out a special resolution LDR campaign in September. And the results are shown in the next section. The Odour management plan also was intended to monitor the landfill at the fence line and also the complaints for the receptor. At the fence line, the site has a prescription for monitoring the concentration of odors with 2 IOMS, and also the H2S concentration, which was carried out with a Jerome analyzer. And then we also employed 2 odor prep systems for on-demand air sampling. And we see here the results from day 1 to day 120, from the 1st of May to the 31st of August. And in such period, we had 120 exceedances of the set values of H2S and other units, with an average of 30 per month. When I say exceedances, because of the local Environmental Protection Agency set 2 thresholds. One threshold for the H2S, and H2S must not exceed 40 ppb for more than 5 minutes. And in terms of other concentration, the other concentration must not exceed 500 other units for more than 5 minutes. And so we have a lot of exceedance of such thresholds in the summer period, as you see. And also the complaints, the plant management provided citizens with an app called Nosy for other complaints registration. And you see here in the period from May to August, we recorded 28 complaints from the citizens, the majority of which were with high intensity. The situation was quite critical, so we carried out an odor reduction program. An odor reduction program must be based on identifying and characterizing the sources of odor emissions. So 2 hypotheses can be carried out. The first one is that we have fugitive emissions in terms of leaks from single isolated wells, one here, one there. And the second one is that we had the poor biogas capture in specific zones of the landfill. So we carried out a specific campaign in September where 85 wells were characterized for pressure, composition, and leaks with the optical gas imaging. As you see here in this image, you see the landfill, and in this area we have very high emissivity zones with very high concentrations of VOC, more than 10,000 ppm of VOC in this area. And all the wells which exhibited this very high values of VOC also were characterized by positive relative pressure in terms of biogas capturing. We have to remember that the optimal relative pressure for biogas capture is around minus 0.1 millibar. So when we see positive values, they are related to pressure imbalance in the suction network for biogas capturing. So the reduction measures we decided to undertake were the following. First, drilling new uptake wells, and so the wells were increased from 301 to 364. And the second, which was the most challenging, was modifying the position of the LFG blower flares in order to optimize the distances between the low efficiency captured zones and the blowers. As you know, a landfill, the biogas is not even distributed all over the surface. So you cannot use and place the blower flares according to a geometric criteria. And so we carried out a trial and error procedure in order to achieve negative pressure in each well of the network. And then we carried out also checking and repaired all the valves and the connection, and the optical gas imaging was employed for quality control after repairing. All the reduction measures were carried out in very few days, 15 days. Results of the odor reduction program. If we compare the data of May, August, compared to September, December, the next months, we can see that at the source, the specific emission rate of methane dropped from 0.12 to 0.04. Also, the exceedances at the fence line dropped from 30 per month in the summertime to 5 per month, and also the complaints for the receptor went from 28 to 1. But in order to understand if this reduction was due to the different period, because we have here the winter time as compared to summertime, we had the chance to compare the data with the homogeneous period, August to May 2019 and August to May 220. And so the results are interesting in terms of 98th percentile of odor concentration measured by IOMS. In May, August 2020 was 100 odor units as compared to 440 of the previous year, with a reduction effectiveness of 75%. And 70% is also the reduction effectiveness we recorded in the H2S concentration, which dropped from 34 to 9 ppb. So, in conclusion, this was an example of a complex integrated odor management plan and odor reduction program. We employed different technologies for different purposes, flux emission and leak detection and repair at the source, IOMS and specific sensors at the fence line, and citizens' complaints registration for the receptors. By using these complementary technologies, we were able to identify the specific problem, the poor biogas capture, and we were able also to identify specific and measurable performances like biogas flux, number of wells with low suction, number of complaints, and so we were able to quantify the effectiveness of an odor reduction program. In terms of year-over-year comparison, we had the 75 reduction of 98 percentile of overall concentration at the fence line. And most important thing, we had over 90% reduction for citizens' complaints, 2 complaints versus 28. Thank you for your attention.
Thanks, Federico. time for fast question and fast response. No question? No? Ah, great.
Sorry, probably I don't understand in which way the VOCs was evaluated during these the different campaign. Is used IOMS or other instrument?
The VOC on the source was measured by a FID,
Okay.
a portable FID, on the
Okay.
surface of the landfill,
Okay, thank you.
for identifying the most critical zones near the wellhead.
Okay, perfect, thank you.
Okay, so I don't see any more questions. So thanks again.
Thank you.